Once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to respond to a question in shape and space 9. That is in exercise 2 star and question number 2 under revision. And in this question, it's question number 4. We are told that the diagram shows a wedge where AB is 14, and we can see AB is 14 and BC is 18 as illustrated above. ABCD is a rectangle in a horizontal plane. ABCD is of course a rectangle. ADEF is a rectangle in a vertical plane. P is 1/3 of the way from E to F. P is 1/3 is 1/3 of the way from E to F. And we are told that since the base is a rectangle and this one is a rectangle, so BC is very much equals to FE, or CB is equals to EF. And because if this is 18, the whole of this one is also 18. And we are told that P is 1/3 or 1/3 of the way from E to F. What do we do? How do we get now? How far is P from E? It is 1/3. 1/3 of 18 is 6. So we can clearly say that EP is 6 centimeters. And that is very important for us. So what else? PQ is perpendicular to AD. PQ is perpendicular to AD. There's an angle of 90 there, and there is an angle of 90 D. PQD is 90. And we are also told that PQC is also 90 degrees because QC in this case now represent the bottom plane. The angle between PC and the plane ABCD is 30. The angle between PC and the bottom plane, which is ABCD, is 30 degrees, as you can see. Calculate the angle between PB, the angle between PB and the plane ABCD. PB and the plane ABCD. Again, the bottom plane. One thing we must know is that in triangle PQC, that is where we find the 30 degrees. QC represents the bottom plane, and PQ is the height of this particular prism, or the perpendicular height of the wedge-shaped prism. QP is a common height of both triangle PQC and triangle PQB. Because what we need here, we are going to have triangle PQC, which is 30 degrees. This is P, this is Q, and this is C, and this is 30 degrees. We have that. What we need from here is what is the common height PQ? That one we must get. But before we get even there, triangle QDC. Triangle QDC is going to give us the length of QC. Triangle QDC. And how do we find triangle QDC? It is right angle at 90 degrees. Therefore, we have something that looks like this. This is Q, this is D, and this is C. And we are already told that PE is 6, which is equals to QD. So this is 6. And we know DC is the same as AB, which is 14. That is 14 centimeters. So what is QC? QC, we should know using the Pythagoras theorem from this for this particular diagram, 6 squared plus 14 squared is equal to QC squared. And let us just find out what that is. Let us just find out what that is. 6 squared plus 14 squared is equals to, so the root of 323 is 2 root 58, which is 15.2, approximately 15.2. So you can say QC is 15.2 centimeters. The reason why we have QC is to help us get the height PQ. And because if this is 15.2, then if we call PQ like X, we can already know, according to SOHCAHTOA or trigonometric ratios, the tangent of 30 degrees is opposite over adjacent. That means from where we sit, the tangent of 30 degrees is the opposite, which is PQ or X, all over the adjacent of the angle in this triangle, which is 15.2. And X, as we can see, X is basically 15.2 multiplied by 15.2 multiplied by the tangent of 30 degrees, which is what? Times the tangent of 30 degrees. What is that? This is 8.8. 8.8 almost. So PQ is 8.8 centimeters. This is 8.8 centimeters. Even if you were to fill it in the diagram, original diagram. Now we don't know exactly which sides to use as we calculate the angle PBQ, because for us to get the angle between PB and the horizontal base, we have to use a triangle that is, let's just put it over here. We have found that this is 8.8 centimeters. This is P, this is Q, which is 8.8 centimeters, PQ. And we have now the PB. We don't know what is QB. And in this case, the QB represent the base. It represents the plane, the rectangular plane that is at the base. So by all means, we have to be able to calculate now the length from Q to B. And how do we do this? If we can extract a triangle, and what triangle are we going to extract? Because we know the base is a rectangle, it is also 90 at that particular point. So we can easily talk about P, Q, not P but A, Q, it is right angle at point A, this one, and then we come to B, this is point B. And because we know AB is 14, is already given, and AQ is 2/3 of 18, because the original length from A to D is 18, and we know QD is 6, as we can see there. So the remaining length is 12. So AQ is 12 centimeters. If that is true, then we can talk about BQ, like 12 squared plus 14 squared. Let us find out what that is. 12 squared plus 14 squared is 340. The root of answer is 2 root 85, which is approximately 18.4 centimeters. So this is 18.4 centimeters because 12 squared plus 14 squared is equals to QB squared. Now the root of that is what has given us 18.4 centimeters. So we can now substitute BQ, which is BQ. It is the one which is also here, 18.4 centimeters. And now we can easily identify our triangle PQB, and we need this angle alpha. That is the angle PBQ. This is the angle alpha that we require. This is PBQ. Now it goes without saying, now the tangent of alpha is equals to the opposite, which is 8.8 over 18.4. And what is this? 8.8 divided by 18.4, it's giving us 11 over 3, and we can also write it in decimal form, which is 0.4783. And because we are looking for the angle, we are talking of shift tan. The shift tangent of this is going to give us alpha. So alpha in degrees is tan inverse of 0.4783. In other words, shift tan of the answer, which is going to give us 25.5 degrees, and therefore alpha is 25.6 degrees. And that is the answer to that question. Please follow and make sure that you understand all the steps so that we can understand this nature of questions. Thank you, and let's meet in the next video. That was quite a long question, but very important for all of us. Thank you.